Hi guys, so if you missed the class, I did a simple demo since we are going over the basics of circuit. So I built a very simple circuit. So for that you need a power supply, power source. So here I have 3 batteries in series. So it's a double A and it's 1.5 volt, 1.5, 1.5. So you have 4.5 volt available. You have the positive is here. That will be the positive terminal. That will be the negative terminal. If you want batteries in series, you want to make sure that the plus is connected to the minus, the plus to the minus. Okay, and then I need to make a path for the current to flow. So I have a switch here and I have a load. The load is just a light bulb. Okay, so I'm gonna connect everything with conductors. So I can use aluminum, piece of aluminum if I want. This is just copper wire and it's insulated. Okay, see, so I'm doing the connections. It's very simple. It has to make a closed path. Okay, so the current can flow from the plus, deliver energy to the load. So electrical energy is turned to light and heat, and then the current come back here, get a boost of energy again, and it keep repeating itself. In reality, it's really electrons and moving, and they are not really moving, right? But let's not talk about that. Let's just imagine that you have current flowing, right? So positive charges flowing here. So inside the batteries, you have some chemical reaction that will release some chemical energy. That chemical energy turn to electrical energy, electric potential energy that is delivered to the load. That electrical energy turn into light and the cycle repeats itself. So here I have a switch. You see, this is air. Air is an insulator, so the current cannot flow unless you apply a very high voltage, like 3000 volt, for example, for a few millimeter. Okay, so then you can have a breakdown, but otherwise it's a good insulator. Close the switch and voila. Okay, so if you want to do some measurements, you can take your multimeter. So the black here is in the, here it says COM, means common ground. The red is in volt. So I'm measuring volt. You want to take the maximum here. So here you have 2 volt, 2000 millivolt, 2 volt. That's not enough because I have 4.5. So here it's going to be 20 volts. So that's good. I have that way I have 2 decimal. And you take your probes here and you go across the load. So you see it's about 3.7 volt. Okay, so if I go across the power supply here, I have about 4.2 volt. So between 3.7 and 4.2 volts, some voltage drop happens maybe across the switch or across the wires. Okay, so we call that, when you're measuring the voltage, this is called a voltage drop. So 3.6 volt, and here I have about 4.1 volt. Okay, I don't know how much I have across the switch. I have a 0.2 volts, something like this. So if you add all the voltage, so the voltage across the switch plus the voltage across the load, it should add up to the voltage across the power supply if you neglect the voltage across the wires. This is a cheap circuit, you know, because you're not supposed to have a voltage drop across a switch. Okay, it should be only across the load. So anyway, if I want to measure the current will be the same. Doesn't matter where I'm measuring current. It should be the same all over, because you can imagine it's like, first of all, it's flowing in this direction from plus to minus. So it's like water flowing. There is no leakage anywhere. So it should be the same current. Current will be the amount of charge flowing through a section per unit second. So for example, if I measure 2 amps, that means you have 2 coulomb of charges being produced at the terminal here and flowing per second and flowing here. So that will be the amount of current will be discussed in class. So how do we measure current? So here we have to be very careful not to blow a fuse. So I don't expect large currents. I'm going to stay here and say milliamp. Okay. So first of all, you open the connection. You're going to connect. I'm going to remove the switch. So now your device has to be part of the circuit. Okay, it has to be part of the circuit. It's like a load, except the resistance is so small that you should not have any voltage drop across it. So that's why you want to make sure that you don't have too much current going through it, otherwise it has a fuse that will burn. Okay, so you still have your circuit here through the load into the device and then back to the negative terminal, right? So I still have my circuit here and I don't want to go here. No, don't do that, because the voltage has a very high resistance here on that side here, so the current will not be able to flow. But you want to go on that side here where it says amps. Let's see, what do we have? See, 200 milliamps. I have a 1, that means it's more than that. So I'm going to go to 20. 200 milliamps. And so I have more than 200 milliamps. So I have to stop. And here I have to go to amps. So you unplug that and go to amps here. And here it says I have 0.36, about 0.36 amps or 360 milliamps. So be careful with that. Okay, so if you're measuring amps and you put your voltmeter your device across a load, it will make a short and it will fry. So you have to be very careful. When you are measuring current, you have to make a large load. Okay, now I don't need to have a bulb. I can have another kind of energy, turn electrical energy into mechanical energy, into kinetic energy. And here I have a motor, right? So the motors, it consumes a lot of amps. So it's going to drain the battery quicker. And if I measure the amps now, am I still connected? Okay, so if I measure the amps, now I have about 0.04 amps. Okay, so it still drains. It's draining a lot of amps, but the other one as well. So that will be about 40 amps, milliamps, 40 milliamps. The light bulb also was draining a lot. I forgot 0 point something, 0.3. So this one is draining more current. The voltage is the same because the power supply is the same. So what if I put like a small, another kind of load? This one is polarized, so I have to be careful. This one has to be connected to plus. And you see 0.02 amps. Now, if I connect those two things together, that will be very bad because I make a short, there is no load, and the wire will get hot very quickly. There is no resistance anymore in the circuit, so the current can flow like crazy and it will drain the battery. So that's very, very simple. Again, if you want, you don't even need to put the switch. Here you have the circuit here, high power supply, load, connecting wires here and there. The positive charges here move from plus to the load into the minus. Okay, so from here they get a boost, and then that energy is delivered to the load, and then the charges, they come back without energy. That's one way to look at it.